Okay, so there will be two sets of formulas since this is a constant acceleration, right? So na horizontal or vertical. So if we recall to ang formula for constant acceleration. So this is constant acceleration because the acceleration, the acceleration due to gravity or gravitational acceleration is just the same. That is 9.81 meters per second squared at any time. So the first constant acceleration equation from the kinematics equation we discussed earlier. I would like to discuss this first. We have the final velocity is just equal to the initial velocity plus or minus the acceleration times the time. And then we have the position is just equal to the final position is just equal to the initial position plus the initial velocity times time plus and minus 1 half a t squared. And then the third one, we have the square of the final velocity is just equal to the square of the initial velocity plus or minus 2 times the acceleration, and then the displacement, the initial position minus the final position minus the initial position. Since we have two components, no, so in the projectile motion, so if this is the motion, let's say this is the velocity, then we have the velocity along x horizontal component, and then the vertical component of the velocity we call the vy. So let's first get the horizontal components equation. So from this equation we can come up with the with the equation for each of the components, the horizontal and the vertical. But before that, I would just like to discuss that in a projectile motion, say this is the projectile motion, and let's say it moves like this. It has a velocity, and then this is the horizontal component of the velocity vx, and then the vertical component of the velocity vy from this point. So it moves like this until such time it reach this, like that. So instead of using the s position, we use the x, or sometimes we use the r or range. The range is the total distance traveled of the particle from the starting position to the final position. And then sa vertical component, we use y or h, depends on the situation. So now let's talk about the horizontal component of this constant acceleration formula. So first we have the velocity is just equal to initial velocity plus or minus acceleration times time. So ato ang i-take ang horizontal component, Vx is just equal to Vox. Since this is a, yes, so the x component or the horizontal component of the initial velocity. Since the direction of the acceleration is downward, it means that it is vertical component and this is horizontal. And there is no horizontal component of the gravitational acceleration. Therefore, this is a 0. And we have an equation which says that the final velocity is just equal to the initial velocity along sa horizontal component. So Vx, so the velocity then of the projectile motion, it's along its horizontal component from the starting position until the in any position is just the same. It doesn't change through time. Okay? So the second equation, we have this s. So instead of s, we use the x. So s is just the final position is equal to the initial position plus the initial velocity times time plus or minus 1 half at squared. Since the acceleration along x, so this automatically cancels out. So we have the x is just equal to the initial position x naught plus the Vox, the initial velocity along x, or the horizontal component of the initial velocity, times time. And then our third equation for the horizontal component, we have the Vx squared is equal to Vox squared plus or minus 2a x minus x naught. Since there is no acceleration along the horizontal component, automatically this becomes 0. So Vx is just squared is just equal to the horizontal component of the x initial velocity squared. And since we can simplify this equation by extracting it to the square roots, we have a final answer of Vx is equal to Vox, which is similar to the first one. So in the horizontal component, we have two equations. We have this Vx, which is equal to Vox, the final horizontal component of velocity along x. Yes, the horizontal component is just equal to the horizontal component of the initial velocity. And this one, dx, is just equal to x naught plus Vox t. Now for our vertical component, so we now take into consideration the acceleration. So atong first, we have the Vy from this equation is equal to the Voy. And since this is a negative acceleration, so minus, and then we use the symbol of g since our acceleration is onto the gravity, minus g t. For the vertical component, so for vertical component, instead of s, so we use, in the horizontal we use x, so in the vertical we use y. So this equation, constant acceleration equation, then becomes to y is just equal to y naught plus Voy times time minus 1/2 gt squared. And for our third equation, it becomes Vy squared, which is equal to v initial, the vertical component of the initial velocity squared, minus 2g times, since this is x, it talks about the position, and our position along the vertical axis, we use or denote it into y. So we use the symbol y minus y naught. So for the motion of projectile, we have 5 equations.